Okay, so some of the definitions that we're going to talk about today. A rectangle. A rectangle is specifically defined as a quadrilateral with 4 right angles. Okay, quadrilateral with 4 right angles. A rhombus is specifically described or defined to be a parallelogram with 4 congruent sides. 4 congruent sides, or quadrilateral with 4 congruent sides. Whereas a square is defined to be a parallelogram with 4 congruent sides and 4 right angles. Okay. What's interesting about that picture on the right is that some of the things we know about quadrilaterals in general. What do we know about a quadrilateral? There's 2 things. It is what? How many sides? And the interior angles, not the sides. The interior angles add up to what? 360. The measures of the interior angles add up to 360. How about a parallelogram? Do the measures of the interior angles add up to 360? How about a square? Do the measures of the interior angles? Rectangle, rhombus, all of the things down below from a quadrilateral have all of the properties of what a quadrilateral is. Okay, so a quadrilateral is made up of 4 sides, and all the interior angles add up to be 360. Everything below has those properties. Okay, everything down here has those properties. In terms of a parallelogram, what do we know about a parallelogram? We know that the opposite sides of a parallelogram are parallel. We know that the opposite sides of a parallelogram are congruent. We know that the opposite angles in a parallelogram add up, the opposite angles in a parallelogram are congruent. We know that the consecutive angles on a parallelogram are 180. Okay. We know that the diagonals bisect each other on a parallelogram. We know all of those properties of a parallelogram. All of those things hold true for a square. All of those things hold true for a rectangle and a rhombus. On a rhombus, the diagonals bisect each other. Why? Because that's true for a parallelogram. On a square, consecutive angles are supplementary. Why? That's true for a parallelogram. On a rectangle, the opposite sides are congruent. Why? That's what happens with a parallelogram. That makes sense? Okay. All of those things are true. If we look up here, there's certain components of rectangles. All these first 4 right here, these are actually the properties that come from parallelograms. So are those 4 opposite angles congruent, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisecting each other? Are all 4 of those true for rhombi, which is plural for rhombus? If those that I circled are true for a parallelogram, they are automatically true for a rhombus. Okay? Any questions on that? What makes a rectangle special? All 4 angles on a rectangle at right angles are 90 degrees. What makes a rectangle special is that the diagonals are congruent on a rectangle. The whole diagonal, so like this piece and that piece. Those are the same distance. Those are the same length. Okay, that's what makes a rectangle special. What makes a rhombus special? The diagonals are perpendicular to each other. That means they intersect at a 90-degree angle. Okay, they intersect at a 90-degree angle. For what it's worth, when I was in geometry as a sophomore in high school, I remember getting that question wrong, being really frustrated. Because I'm like, that's easy. I should just memorize it. Yep. The diagonals of a rhombus also bisect the opposite angles, which means in the picture, these pieces are congruent. Same with these guys. Okay, it's bisecting. They bisect the opposite angles. Okay? Okay, we have to answer these questions always, sometimes, never. There's some interpretation that needs to have with these. There's some conversation that we need to have. We're going to write down one word, but we need to interpret what that word actually means in the context of the question. All right, always, sometimes, never. These are always hard. Okay, the diagonals of a rectangle are perpendicular to each other. Is that always true? The easiest is always. Is that true all the time? No, that's not true all the time. Look at the picture on the right. We just drew them in. They're not at 90 degrees on a rectangle. Okay? Could they be perpendicular? Is there a particular rectangle where they are perpendicular? A square. Remember we started the class by saying a square is a rectangle? So everything, if the diagonals are perpendicular, they happen to be a square, it could be. This is a sometimes. It could be a square, which makes that question hard. How about number 2? Consecutive angles on a rhombus are congruent. Congruent, consecutive angles. You need to think about what a rhombus looks like. You need to think about what consecutive angles are. Always, sometimes, never. What do you guys think? That's a relatively skinny rhombus. Okay, assume all sides are congruent. Are those consecutive angles congruent? Is that angle right there the same measure as this angle right there? No. Sometimes it is, though. It's only sometimes. They're only congruent when they're both 90, which means they're square. Right? If they were congruent, they would both be 90. They would have to be. Then we would have 90-degree angles and congruent sides. That's a square. Number 3, a rectangle has at least one right angle. What's the definition of a rectangle? 4 right angles. So does it always have one? Yeah, that's always. Diagonals of a parallelogram are congruent. On the picture up above, is this blue line, if it's drawn right, congruent to this green line? Are those congruent? Or if you squish that parallelogram in really, really tight, are they congruent? No, not always. In what cases would they be? It's a sometimes. In which cases would they be? A square? In what other case? If it was a rectangle. Diagonals of a square bisect opposite angles. Always, sometimes, never. This one's always. Why is it always, though? That's 90, but why? A square is a rhombus, and it's true for a rhombus, which means it's true for a square. If it's true for the figures up above on this chart, on the shape, again, this chart right here, it's true for everything down below. Everything that's true, again, everything that's true about a quadrilateral is also true for everything down below. Everything that's true on a rectangle is true for everything down below. So a square. Okay? Not everything true about a square is true about the stuff up above. Some of it is, not all. Okay, in the picture at the right, well, that's no fun. I give the last 2 answers. In the picture at the right now, what shape is that? How do we know it's a rhombus? It says it in the directions. Okay, so we need to respond that it's a rhombus. Okay? If that's a rhombus, is OM 13 as marked? As with what's marked in the picture. DO is 13. Is OM also 13? If you say true, you're claiming that the diagonals of this rhombus bisect each other. Is that true for a rhombus? Yes. Let's do 8 first, and then we'll go back to 7, okay? MD congruent to PL. Is MD congruent to PL? If you say true, if you're saying true, you're claiming that the diagonals on a rhombus are congruent. Is that true? Diagonals are congruent on a rectangle, not on a rhombus. This one's false. Makes number 7 easier. Is PL then 13 in this picture? It's false again. You're claiming that the diagonals are congruent, right? Because DM would be 26, whereas PL couldn't be 26 if it's just around. Well, I mean, I guess if it was a square, but we don't know it's a square, so we can't say true. Oops. DLO is DLO. Is that the same as this angle right here? Is that the same as this angle, LDO? The green angle and this purple angle, are those the same? On a rhombus, are they the same? Could you push this rhombus over, like the DL on top of this rhombus, like push that segment off to the side, like tilt it even more? Would it still be a rhombus? It would. If we just moved the angles, like shifted it over and made it more pronounced, more slanted. Does that make sense? To the left. The picture. The purple and the green are not congruent. Okay. They would be congruent if the diagonals bisected a pair of opposite angles. Okay. These diagonals don't bisect those angles. It's not true. That's only true for us. Wait. No, it does. Hold on. I retract that statement. These two angles, those two angles right there, those are supplementary, which means they add up to 180, but they're both not 90. They would both have to be 90 for this statement to be true. This is false. LDP, is that the same as LMP? LDP, LMP. You're talking about opposite angles in a rhombus. Are they congruent? Yeah, that one's true. Opposite angles are congruent. That's true. And then the next one is false. That's saying that two consecutive angles being congruent. That's not true. All right? Go to the next side. Read the question carefully. Read the question carefully, and answer the first one. Read it carefully, then answer the first one. Okay, first, read the directions. I said read the directions carefully, and then do the question. What does the directions say that each one of these shapes is? Nope. Identify each parallelogram. So no, it's not. It's in the directions. We're telling you it's a parallelogram. So you have to respond to that as being fact. So it's a parallelogram. If it's a parallelogram, we know that the opposite angles or the opposite sides are parallel. We know this. That's true. That's true. If that's true, if it's a parallelogram, we also know that the consecutive angles are supplementary. So this angle I'm going to label as angle 1, and the angle labeled as angle 2, those are supplementary, which means they add to 180 degrees. One of those two is 90, so what does the other one have to be? 90. They're all 90-degree angles. They're all 90-degree angles. Okay? That is a parallelogram. or that is a rectangle. Number 2, Josh, I'll answer your question in a second at the end. I won't have time during class, though. Number 2, what is that? That's a square. Number 3? Number 4? None. It's just a parallelogram. Guys. Number 5? Number 6? Okay, it's a parallelogram. Parallelograms have opposite sides congruent. This is just a parallelogram. It's not a rectangle. It's not a trapezoid either. This is a parallelogram, so it would be none. Let's go down below. We're gonna, on these first set of questions right here, it uses this shape. What shape is that? No, that's not a square. That is not a square. Why is it not a square? Stop looking at the pictures and determining their shapes, right? We got to get past the fact that we're not in elementary school anymore. You have to respond to what we know to be true. The general shape of it, we do not know it to be true. We only know that there's 4 sides and there's 2 diagonals in it. That's the only thing. Got to get past that. Things are not always what they seem. We need to live there. Okay, BO. What's BO besides what I have right now? What's BO? That was a funny joke. What's BO? It's BO 10? What's OC? We don't know. It's not 10. It's not 10. If it was 10, this would have to be a square. We don't know it's a square, so we can't say that OC is 10. We do not know that the diagonals are congruent. If we knew that the diagonals were congruent, if we knew it was a rectangle or a square, we would be okay, but we don't know that. We just know it's a rhombus. So we don't know. How about AC? We don't know. This is the only situation where you can put IDK and get the question right. Please don't put IDC. BD. What's BD? 20? AOB? Don't be like me when I was a sophomore in high school and get really angry that you didn't know that that was 90. Why do we know it's 90? It's a rhombus. Rhombus have diagonals that are perpendicular and that bisect each other. ABC? Better not say it's 90. If you say it's 90, you're implying it's a rectangle or a square. You do not know it's 90. How about I tell you it's 90.00001. Okay. What? You don't have to round. It doesn't say to round. If it's not 90, it's not 90. I know. ADV? ADV? You don't know. DCA? Don't know. Because there's no indication that it's a rectangle or a square.